Hi everybody, this is Pre-Calculus, and this lesson covers a review of absolute value graphing. Alright, so first up is our basic form of an absolute value problem, and it was A, and then our absolute value, well first we have f of x equals A, our absolute value sign, x minus h plus k. Make sure that looks like an h there. Okay. K is going to move up and down. H is going to move our graph left and right. But we have to change the sign because it's minus H, right? So minus a negative would be positive. Alright, and then A value is going to change the slope of your lines. Alright, so if A is greater than 1, we're going to get a bigger slope. The graph is going to get skinnier. Right, because if we have a slope of, let's say, 2 over 1, that means go up 2 over 1, right? Kind of looks something like that. If we have a graph of 3 over 1, that means we go up 3 and over 1. See how your graph starts getting skinnier and skinnier, right? The further you get, the higher the number goes, further you get from 0. If A is a fraction, right, less than 1 but not a negative number, that makes less slope, and your graph gets wider. If A is negative, it flips it upside down. It's going to open down. Like that. Right, here's a wide one, and here's a skinny one. Okay. H moves it left and right. Make sure you change the sign. K moves it up and down. Your vertex is HK. Okay, and your vertex is the place where it changes direction. The parent function is written as f of x equals the absolute value of x. And then the A, H, and K are added to that. Alright, we'll graph a couple. I got a graph over here. Alright, first we'll do our parent function. I'll do each of these in a different color. Make this a little thicker. So f of x equals the absolute value of x. So if f of x is, remember, f of x is just y, right? So if x was 0, then y would be 0. If x was 1, y would be 1. If x was negative 1, y would be positive 1, and so on and so forth, all the way up in a 45-degree angle there. Let's see if I can make a line on that. that's not the right kind of line. I want a straight line. Make it a little thicker. Give it an arrow on the end. Nope, wrong end. There we go. And make it purple. Like that. And then make another one on this side. Like that, basically. Alright, so there's our parent function. Let's do one with, let's do g of x equals negative x minus 2. Okay, so this negative means that it's going to be facing down. It's going to open down. And that our vertex, let's see, is hk. Here's our h value. Our k value will be out here. So k is 0. Our h is positive 2, right? Because you have to change the sign. Which means that we're going to move right 2. Right? So our vertex should be at 0, 2. So my x value is 0. No, that's not right. It's hk. So it would be 2, 0. There we go. So we're going to go over 2 and 0, and then it's going to slope down. Actually, that's terrible. Let me get rid of that. There we go. So we move down 1 over 1, down 1 over 1. So right about there. Right, and we could put some values in there. Let's say that x was 3, so we would have negative absolute value of 3 minus 2. 3 minus 2 would be 1, be negative 1. So there, and there's negative 1 right there. Alright, let's draw that one in. Okay, so there's that one. Alright, and then if we had g of x equals negative x plus 2 minus 2. This one right here, our h value is negative 2 because we changed the sign, and our k value is 2, so my vertex is going to be hk, so h is negative 2, k is also negative 2. So my vertex is negative 2, 2, and it's going to face down. Negative 2 right there. Actually, let me change the color on this. Make it pink. And that'll face down. So it's going to follow that one pretty much. No, you're supposed to be making another line. Something like that. Alright, that'd be this one. Alright, x and y intercepts. The x-intercept is where the graph crosses the x line. Okay. So that's where it crosses the x line. So that means that y equals 0 in that position. The y-intercept is where the graph crosses the y line. So that means x equals 0. Alright, so let's graph a few and figure out what their x and y intercepts are. I have to get rid of some stuff here. Let's see. That made some room. That wasn't what I meant to do. Let's get a coordinate plane on here again. Here we go. Alright, we've got g of x equals x minus 2 minus 2. And we're supposed to find the x and the y intercepts of this. Okay, so we need the places where it's going to touch the x line and the y line. So we could graph it and find that out. So that this means that our vertex is at HK. H would be, this would be 2, negative 2 is our vertex. The y-intercept doesn't matter very much on these. It's your x-intercept that matters. So if I go to x equals 2, y equals negative 2, and this graph is going up, so that would be there, there. It's touching right here. This way it's going to touch right here at 0, 0. So those are my x-intercepts. How could I figure that out without graphing? Well, what I have to do is figure out what it would be if y equals 0. So I could say the absolute value of x minus 2 equals 0, right? So that'd be if y equals 0, because g of x just means y. So you set the whole thing equal to 0, and then solve. So I'm going to do plus 2, and I get the absolute value of x minus 2 equals 2. But then I have to get rid of this absolute value sign, I have to do the positive and negative outcome. So I could say x minus 2 equals 2, and x minus 2 equals negative 2. Then when I do plus 2 right here, I'm going to get 4. And if I do minus 2, I'm going to get 0. See how my x value is 4, and my x value here is 0. So I have two answers, because it crosses the line in two places. So you would set this up as what's x? X is, the first one is 0, and y is also 0. And then the next one, x is 4, right here. This is 4, 0. Okay, so it's going to be 2 order pairs in a set for that one. Let's see if I can get rid of this without erasing my coordinate plane there. Yes. Alright, let's do another one. Okay, so I've got g of x equals 2x is 2. Okay, so on this one, my vertex, which is HK, I've got H right there, There is no k, so k would be 0. So h, my vertex is h, which would be, change the sign to positive 2, 0. Okay, positive 2, 0. But my slope is different on this one. So if I made like a little x and y chart, I could work it out that way. Or I could just solve, let's see, we'll do the x and y chart. So if x was 0, what would y be? So I'd say 0 minus 2, 0 minus 2 would be negative 2. Absolute value negative 2 is 2. 2 times negative 2 would be 4. Okay, if x was 1, 1 minus 2 would be 1. Negative 1, that would just be 1. 1 times 2 is 2. If x is negative 1, negative 2 would be negative 3. 3 times 2, that would be 6. Oh, what was this? This was 4 or something. Let's see. Negative 2. 2 times 2 is 4. Yep. Okay, let's try 2. 2 times 2 is 0. 0 times 2, 0. And then 3 minus 2 would be 1. 1 times 2 is 2. Okay, so if I go 3, I'm going to be at 2. If I go 1, I'm going to be at 2. See how it's mirroring itself? So when you're doing this, you only really have to work one side and then just mirror the other side. So I've got my vertex, I've got 2 points. Now I've got 0, 4 right there. See how I'm going up 2 over 1, up 2 over 1. So there. Negative 1 was 6, so that's there. And that means that this one would be here. So if I plugged in 5, I should get 6 as my answer. So there's that. But where is it crossing the x line, the x-intercept? Well, it's only crossing it once at point 2, 0, which is the same as the vertex. Now, if I wanted to solve this without graphing it, all I have to do is set that equation equal to 0. X minus 2, right? And so I could say minus 2, negative 2 equals absolute value of x minus 2. And then I would have to do the negative and positive values. So x minus 2 equals 2, and x minus 2 equals negative 2. We get x equals, see, nope, that's not right. Hang on. Set that up wrong. Let me erase all this junk out of my way. There we go. Okay. Alright, so we set that equal to 0. 2 times x minus 2 equals 0. Alright, oh, so I got to divide it by 2. That's what I have to do. 0 divided by 2 is just 0. So that would be x minus 2 equals 0. You can't have a positive and negative 0, so then you do plus 2, x equals 2. So there's only one spot where it crosses, because 0 can't have a positive and a negative. Right, so that's our x-intercept. If we wanted to find our y-intercept, we have to solve for what it is when x equals 0. So all we have to do is plug 0 in for x. So our x-intercept we already figured out was 2, 0, the same as the vertex. Now our y-intercept. That's going to be where it crosses our y line right here. So we just plug 0 in. So we're going to say g of x equals 2 times 0 minus 2. 0 minus 2 would be negative 2. Negative 2 times 2 would be, oh, absolute value of that would be 2. 2 times 2 is 4. And right there it is. There's 4. So when x is 0, y is 4. B 0, 4. Alright, pretty easy. Pretty easy. Alright. see what else we got. More complex notations. All right, so on this one, it's set up a little bit differently than some of these others were, because we got some extra numbers in there. All right, so this one has f of x equals 3 times negative 3x minus 3. All right, so we're going to graph that, and we're going to use an x and y chart. So if we got our x and y chart here, and we said x was 0, we would have times 0 minus 3. Well, that would just be 0, negative 3, absolute value of negative 3 is 3. 3 times 3 is 9. All right, what if we did come on, give me my eraser. What if we did 1? So if x is 1, 3 times negative 1 would be negative 3. Negative 3 times negative 3 would be positive 9. 9 times 3 is 27. That's too high. We're not really even going to be able to graph that. It doesn't go up to 27. So let's try negative 1. So negative 1 times a negative 3 would be, wait, 3 times 1 is 3. Oh, whoops, did that wrong. That's not times, that's add. Okay, hang on. 3 times 1, that would be negative 3. Negative 3 minus 3 would be negative 6. Negative 6 times 3 would be 18. So when it's 1, it's 18. All right, now let's try positive 1. I mean, negative 1. Okay, so 3 times 1, that would be positive 3 minus 3, that would be 0. 0 times 3 is 0. All right, there we go. All right, let's try negative 2. Negative 2 times negative 3 would be positive 6. Minus 3 would be 3. 3 times 3 is 9. Okay, so I think we've got some kind of a V shape here. We know where our 0 is. So, all right, if x is 0, then y is 9. So x 0, y 9, right up there. Change to, okay. If x is 1, it's 18. We can't graph that. That's too high. If x is negative 1, then y is 0. That's all the way down here. If x is negative 2, y is 9. So that's all the way up here. So that is a crazy looking slope. Very big. Well, that's not cooperating at all. There we go. Okay, so that's what our line looks like. All right, so when we look at this, we would have thought that our slope would have been our A value right there, right? Because there's A. And there's our H. Right? And then K would be 0. That's where that is. H would be 3. So our vertex should be 3, 0. But when we look at the graph, it's not. It's not 3, 0. It's negative 1. So we got to figure out what's happening here. Well, the problem is that we've got this 3 over here that doesn't need to be there. See that? You can't have anything multiplied by your x. Your x has to be by itself in the equation for that formula to work. So to fix that without graphing, all we have to do is change around this equation. Alright, so we're going to change the equation around so that we get that x by itself. And then our numbers are going to make more sense. So if we can divide right here, can we pull out a common factor? If we had negative 3x minus 3, we have the common factor of 3 in there, right? So we can pull that out of the equation. So if we said f of x, and then we had, let's pull out, we can pull out not only 3, negative 3, and what's left? X minus 1, right there. And then we're going to pull that 3 out and put it over here and multiply it times that. But we need the absolute value of it, right? So the absolute value of negative 3 is just 3. So we're going to have f of x, and then we're going to have, actually, was that supposed to be a negative 3? Yes. Alright, so we're going to take the absolute value of that, and that is 3, and then 3 times 3 is 9, times the absolute value of x minus 1. Now that should work out to where our values would work properly. So let's see. If we look at it now, we've got f of x equals 9 times the absolute value of x minus 1. Alright, so our hk, this is our a value, is now 9, and our h is negative 1, and our k is 0. That means our vertex should be at hk, which would be the opposite of h, would be positive 1, and k would be 0. Oh, it's at negative 1. Oh, because that would be plus. That would be plus because we took the negative out. Ah, that makes sense. All right, so when we had negative 3x minus 3, right, we factored out negative 3. So we would be left with x plus 1. So this becomes x plus 1, not x minus 1. Which you change the value. So you swap it when you pull out your vertex value. And so that makes it be negative 1, 0 right here. All right, and that would be also be our x-intercept. And then our slope, our a value, becomes 9. So that would be the same thing as 9 over 1. And when we moved 1 over, we went up 9. All right, let's try another one like that. Okay, I'll just move that over there. There we go. Okay, so we're going to solve a couple without graphing. So we don't really need that graph anymore. Alright, so we've got f of x equals 2x minus 3. And we need to find the vertex and the x-intercept and the y-intercept. Alright, so for the vertex, it's hk, but there's something next to our x, so we got to get rid of it. So we're going to have to divide all this by 2 and pull the 2 out, right? So f of x equals 4, because of my 2 times 2, right? And then my absolute value sign, these cancel, so I got x left. And then I'm going to have 3 over 2, right? Because we're dividing this by 2 and this by 2. So now my h value is right here, and we don't have a k, so that's k0. So the vertex is going to be negative, oh, change that to positive, right? Because we have to change the sign on that. So that would be 3 over 2, 0. Alright, now if I want to find the x-intercept, I have to solve the whole thing for 0. And I could leave it like this. I could say 2 times 2x minus 3 equals 0. Divide by 2. I'm going to have 2x minus 3 equals 0. I can't do a negative and a positive, so I'm only going to have one answer. So I'll do plus 3. 2x equals 3 divided by 2 divided by 2, and it's 3 over 2 is my x. And my y would be 0. So that's telling us that my x-intercept is the vertex. They're both the same, right? So it's one of those ones where we have our x-line, and then we have our vertexes right on the x-line. So we only have one answer. Next, we're going to find our y-intercept, and all you do for that is you plug 0 in where the x is. So to do that, I'm going to say 2 times 2x minus 3, but x is really 0. 2 times 0 is 0. Absolute value of negative 3 would be 3 times 2 equals 6. So my y-intercept would be, y would be 0, x is 0, y is 6. So it crosses the y line at 6. Alright, there's how you solve one without graphing it. Try another one. F of x equals 2 times the absolute value of negative 3x plus 4 minus 3. All right, let me fix that. Okay, so to find my vertex, first I have to fix this equation so that I don't have an x next to that. So I'm going to say 2 absolute value negative 3x plus 4. I need my x all by itself. Nothing multiplying that x. X term can't have a coefficient. So I'm going to divide by negative 3. Negative 3 right there. And then that means I have to multiply this by negative 3. Right? So I'm just pulling that negative 3 out. Right? So like the opposite of the distributive factor. Distributive property, the opposite of rainbowing. So like instead of doing like that, right, we're doing the opposite. Okay, so 2 times negative 3 would be negative 6. And then inside here, these cancel, and I'll have x, that's what I'm looking for, minus 4 over 3, negative 3. Okay, so then I know my a is going to be negative 6, my h is going to be negative 4 over 3, and my k, oops, I was supposed to say h, I know it's negative 6. I know it's 4 over 3. Alright, so that's my h, and that's my k. Alright, so for my vertex, it's going to say hk, and h is negative 4 over 3. Change the sign to 4 over 3, negative 3. Don't change the sign on your k, you only change the sign on your h. Alright, for the x-intercept, I'm going to set the whole thing equal to 0. So 2 negative 3x plus 4 minus 3 equals 0. So then I'm going to do plus 3. And I get 2 negative 3x plus 4 equals 3. Now I have to divide by 2. And I get negative 3, the absolute value of negative 3x plus 4 equals 3 over 2. So then I have to set that equal to negative and positive 3 over 2. Right, because you have to do your negative value and your positive value when you get rid of that absolute value sign. So negative 3x plus 4 equals 3 over 2. And negative 3x plus 4 equals negative 3 over 2. right here, first thing, subtract the 4. So that would be the same thing as 8 over 2, which would be 5 over 2. Negative 3x equals. And then if that was 3 over 1, I can flip and multiply. X equals 5 over 6. And that would be, let's see, that was positive, negative, negative, it's negative 5 over 6. I think, let's see, nope, it'd be positive because this turned negative, and then negative times the negative makes a positive. All right, now this one, minus 4, minus 4. All right, this would be the same thing as 8 over 2. 8, 9, 10, 11 over 2, and that's negative 3 over 1x equals, and then I just flip this and multiply, cancel, cancel, cancel. Negative times a negative is going to make a positive 11 over 6. All right, so it is 5 over 6 and 11 over 6 is the answer. No. These are my x-intercepts, so I need 2 points, right? So y is going to be 0, x would be 5 over 6, and y is 0, and then x would be 11 over 6, and y is 0. There we go. That's how to get the answer to those. All right. There is a possibility that you might run into some absolute value equations that do not cross the x line. All of them are going to cross the y line at some point. They usually don't ask you about where it crosses the y. It's usually where it crosses the x. Now, some of them don't cross the x. Let's imagine that you had an absolute value problem where your vertex was at 3, 1, and it's facing up, right? That does not cross the x line. Imagine you had one that was at negative 2, negative 2, and it was facing down, right? That one's not going to cross the x line, okay? So it's not going to have any x-intercepts. So you got to be careful. Sometimes they don't have x-intercepts. All right, so let's see what that would look like. If we have f of x equals the absolute value of x plus 2, that would be hk. There's no h, that's going to be 0. K is our up and down, that's 2. That would be right here, right? And it's going like that. That is never going to cross that line. If I set this equal to 0, plus 2 equals 0, I would say minus 2, minus 2. So you just got to be really careful. You got to know which ones are not going to cross, okay? So if it is facing up, right, your vertex must be below the x-line. Right, so that means you have to have a negative y value. For your vertex, right? It has to be down here somewhere, right? Below our x-line. All right, if it's facing down, it has to be above the x line, right? So it would have to have a positive y value, right? So for it to be facing up, that means A is positive, right? Our y value is going to be, let's see, if it's HK is our vertex, and our vertex is at x, y, that means K is going to have to be positive, right? So that would be K positive. No, negative. Whoopsie. So if A is positive, K has to be negative. If A is negative, K has to be positive, right? So what that means is A is positive means it's facing up. So K has to be negative. It has to start down here somewhere, right? Then it will cross. Okay. If it's facing down, A is negative, then K has to be up here somewhere, so that it'll cross. Okay. All right, hopefully that made sense. All right, and that is it for this lesson. Thanks for watching.